Okay, so in this video, I'm going to be going through all of the types of graph that you need to know for the A-level maths course, including the first year AS level maths. So, just a bit of a disclaimer, I'm not going to be talking about any transformations of graph. So I'm not going to be stretching it, reflecting it, or translating it up or down. I'm not going to be doing that in this video, because you should be able to do that to pretty much any line, because you've done that in the A-level maths course. This is just a recap and a revision video to put them all together into one. So we'll start with a couple of basic ones. So we'll start with y equals x. The bog standard is now y equals x. Whatever y is, x also is. So that will be y equals x. Okay? So we'll have another one. We'll have a look at y is 2x minus 3. How about that one then? Well, to draw something like that, we know the intercept of the y from your straight line knowledge will be at minus 3, and we need to find out the x coordinate, so let's know y is 0, cover the y's up, so x minus 3 is 0, so I get 3 halves, which is about there, and I get my straight line, like that. The last one I want to look at is 2x plus 5y is 10. Any ideas how we would look at that? Well, cover the y's up, we get an x should be at 5, so I'll be going through here. Well, that'll be when they go, so y should be 2 when x is 0. So 2's about there, isn't it, roughly, something like that. So you'd have a straight line going through 2 and 5, and the gradient you could rearrange into mx plus c, and it would have a gradient of minus 2 over 5 if you're interested. So its gradient will be minus 2 over 5. You can also do that by differentiation if you wanted to. Okay, differentiating implicitly, of course, which is second year stuff. But that's how we can do the bog standard straight lines. On to basic polynomial graphs now. So we'll start with the left one, y equals x plus 1 times x minus 2. Well, that's a quadratic at the roots, which will be, when that's bracket 0, so minus 1 and 2. So I'm going to make this 2 significantly to the right of the minus 1. So 2 will be about there. You could find out where it crosses the axes. Well, that'll be 1 times minus 2, that'll be minus 2. And then you could draw a nice quadratic shape. And you could use completing the square to find out your minimum. Or you could use differentiation. For the second one, so we've got a cubic through minus 1, 2, minus 3. Minus 1, 2, minus 3. So there you go, there's your roots labelled. Make sure I label that one as well, over there. So it's going to start at the bottom left as it's a positive cubic if you would expand that all out. So you go like that. Sound effects are optional. So we got minus 2 times 3 is minus 6 times 1 will give you minus 6. So that is your basic cubic. So that's basic polynomial graphs. Okay, so on to some repeated factors cases now. So we've got y equals x minus 1 times x plus 2 squared. Well, roots here will be at 1 minus 2. Minus 2 will be a bump, so a bit of a repeated root. And that would go minus 1 times 2 squared, so it'll be at minus 4. So you would go, it would actually not do that. It would go that, and it would bounce back down, back through 1. So it would do something like that. Actually, that'll keep going as well. For the second one, we've got y equals x minus 1 squared times x plus 2 squared. Well, this is a cheeky quartic. So it would go at 2 squared times minus 1 squared, so that's 1 times 4. So it's going through at 4. That will be going through at 1. That will be going through at minus 2 with the typical bump. So it's going to like... Now, it kind of looks like a W shape if you squint. Or you can imagine it's something rude, like something else, if that helps you remember it. But that's our basic repeated factor cases. Okay, so moving on to some reciprocal graphs then. So y equals 1 over x. Now, 1 over x has an horizontal asymptote. Basically means it'll get closer and closer, but it won't actually touch it because you can't divide by 0. And obviously I put an improper integrals video out and we looked at integrating 1 over x. As part of that, because you can't physically integrate 1 over x that well, because obviously you'll find that it doesn't actually work. Anyway, besides, 1 over x is two curves, one going one way, so going here, up, and touching down there. And let's get that a bit better, so it's going to go bump down so and get closer and closer like that. And then the other side, so it'll come out from here, go down there. Won't actually physically touch it though. For 1 over x squared, well, that kind of looks like a reflection in the y-axis a little bit. So we're going to go like so, get down there, and we're going to go like that, like that. And obviously it won't physically touch it, but this will get closer and closer, so 1 over x squared will approach infinity, but it won't physically touch it, so it'll converge on it. So you could write that as a limit as a tends to infinity of 1 over x squared. Stuff that we did in the improper integration video if you're interested. Okay, that's how we can look at some of those types of graphs. Now there's one more we're going to have a look at, and that is one that lots of teachers forget, including people at my school forget to do this, and it's y equals root x. Now y equals root x looks like a parabola.
Just a quick pointer here, that y equals the root of x is it is on the Edexcel, AQA, OCR and OCR MEI specifications, so it's not just an X one I'm chucking in, it is on all example specs for AQA, Edexcel, OCR and OCR MEI available. Right, enjoy the video, well, let's get right back to it. Enjoy.
So a quadratic on its side is kind of bent over. Like if you imagine a quadratic like that, it's just like that instead. It's just twisted on its side. So it'll come out like so, and it will head over there. As you get closer and closer and closer, you'll find out your graph looks like something like that. And obviously it doesn't exist past down here because you can't have a negative in the bottom half, because you can't have a negative y in a sense. You could keep going, but it won't happen. It won't exist past here either, because you can't square root a negative. Well, in normal maths world you can't, but you will look at soon the square root of -1 is I, when you look at further maths, and you'll explore complex numbers a lot more using something called the Moivre's theorem, which I do know about. It's in second year, so year 13 content, the Moivre's theorem. You will learn as well, and you'll learn the Maclaurin series as well, and all that fun stuff. That's for further maths anyway. Let's get rid of that. And let's have a look at some more. So that's all your reciprocals and the square root of x graph. Okay, on to some exponential graphs then. So we've got y equals 2 to the x and y equals e to the x. Now, they are very, very similar, but I will show you the difference on a separate graph down here in a minute. So 2 to the x will increase like usual, and it will go through at 1. However, there is a steeper graph than that, and that one is steeper than e to the x, because e is roughly 2.71, so it's a bit more than 2, so it'll have a steeper gradient. So this one will go through 1 again, but it's a little bit flatter. It's still a curve. If you put one on top of the other, so if I do a dotted line, you'll see it'll go through, but then it'll scale off a bit quicker as well. So the dotted one will be 2 to the x, the solid line is y equals e to the x, as e is 2.71 if you've done exponentials and logarithms yet, which is at the back end of first year A-level maths in the pure section. Okay, so that is e to the x and 2 to the x. Okay, let's look at the inverses of these then. So we've got y equals log of x and y equals log base 2 of x. Now these are again quite similar, but obviously as we know, one is going to be steeper than the other from the previous look at the two other previous curves we looked at. So this one is going to go through at 1, but it's going to get closer and closer. And we've got y equals log of x. Now y equals log of x is very similar again, but it's a bit flatter. It's going to be the whole flip of y equals log base 2 of x, so this one's a bit steeper in other words. Okay, that's how we can sketch those for A-level maths. Okay, onto some basic trig graphs then. So we've got y equals sine x. Now y equals sine x is super simple. We go like that. Here will be 180 degrees or pi radians if you want to use pi, and put these into radians. Here is 90 or pi over 2, 270. That's minus 1, of course. Sure, write those. And up here is 360 degrees or 2 pi radians. And 270 is 3 pi over 2. Okay, so that's basic sine x. For cos x, it's pretty much the same, but for cos x, we start at the top and work our way down. So we kind of get like that. Here is 180 degrees, 90 degrees is here. Then we get 270, which is over here, and then 360 is at the end. And we start at 1, minus 1, go to the origin. That's cosine. For tan x, it has its asymptotes. Okay, I'm going to draw 2 in here. So it kind of, it looks like this anyway. I was going to make it complicated, but I don't want to make it complicated. There's 360, there's 90, there's 180 degrees. No, that's 270, so it goes up every 180, doesn't it? There. Okay, so there's the basic graphs of y equals sine x, cos x, and tan x. Okay, onto the reciprocals then of sine, cos, and tan, which I'm going to draw on top of because I feel like it's easier to draw. So cosec is 1 over sine, so we go like that, and it also gets even more cheekier, whereas that dip that's at the bottom will now continue down there, and that's cosec. For sec, so sec is 1 over cos, so we have it here. Even cheekier, it goes the other way, up there, and to make it even more harder, it'll go like that, honestly. It'll extend as well. Okay. Onto cots then. Cot is even weirder, it does a reflection of exactly what sine is. So it will do that way around on it, so it'll go like that. It's a really bad curve, I'm so sorry. You know what I mean though, right? It goes like that. That should actually come over this way a little bit more. Like that. Okay. So those are the reciprocal functions. Okay, now we're on to inverse graphs now. The inverse of sine, sine, cosine, and tan. So sine to minus 1, so inverse sine. I'll draw a little sketch of the sine graph. Kind of goes a bit like that. Sine, okay, there's the origin at 0. So that is our sine graph. Now we wanted to draw arc sine, so that is the inverse. Well, the inverse is just this, just tipped on its head. So here's pi over 2 if you're interested. Minus pi over 2 will be down here, and then the 1s will switch around as well. So minus 1's over there, 1's over there. Then we go it goes through the origin, then carries on down here. It looks a bit like a cubic if you squint. Okay, that's y equals arc sine x. Arc cos x, well, the graph of cosine, as you've just seen in the previous part of this video, got something like that. So if we wanted to draw arc cos x, that's 1 over. It's going to look something like that. Where here is pi over 2, there is 1, here is minus 1, and that would line up there. This top value here will be pi. Okay, so that is arc cosine x. Arc tan, well, let's draw a little sketch of tan. Always nice to see tan first. Okay. Asymptotes, of course. Yeah. So arc tan of x, again, draw your axes. So draw my double axes in. That goes like that. And here are those asymptotes that I just drew a second ago. Okay. So these are minus pi over 2 and pi over 2 in radians. Okay, so that's the inverse trig functions. Okay, this is kind of contradictory to what I just said a moment ago, but y equals mod x, so the modulus graph for mod x, well, it can't exist below 0 because if it goes to 0 it goes back up again. So you kind of get this V shape going on. That's mod x. Now, I wasn't going to include transformations in this video, but I feel like this is important because mod of x minus 1 plus 3, well, x minus 1 will go over to here and up 3. So it goes 1 and it goes up to 3, like so. And you can find out where it will cross when x is 0. That'll be minus 1 modded plus 3. So we're going through at 4. Okay, so it's going to go to here and go through there like that. Okay, so that is the transformation to do that one. But there's the modulus graphs. On to drawing some circles then. So x squared plus y squared equals 25 is the bog standard circle. Should spot that immediately. Going through minus 5, 5, 5, minus 5. Okay. And that is just your bog standard circle. My circle drawing is terrible, but you get what I mean. Now I wasn't going to do transformations in this video, but just for the fun of it, I'm going to have a look at x minus 5 squared plus y minus 3 squared equals 25. We have to spot if it will touch the axes or not. This one on purpose will, so 5 at 3 on the y-axis. So there's my centre, radius 5, square root 25. So this one, it should touch the x-axis. It should not go below though. We should just do that. Okay, that's a really bad circle, but I want to make sure it touches the axis. It will go down and come back up at minus 2. Okay. That's how we can draw circles. Well, not my great circles anyway. Finally then, there's one more I want to cover, and that is this. X is 2 sine theta and y equals 4 cosine theta. Now this you should recognise as an ellipse. Now if you don't know what an ellipse is, you need to go to parametric equations and see all that stuff. I'm not covering that here. But you should be able to draw some sort of reasonable ellipse, more like an oval. It will range between minus 2 and 2 and 4 and minus 4. Okay, because you'd find out here when x is 0, 2 sine theta is equal to 0, and solve the equation as you would. Okay, so that is how we can draw the ellipse, and that is the end of this video. Make sure to like and subscribe and all that fun stuff, and I shall see you in the next video, which I might do the graphs for further maths if you're interested in that. So make sure to like if you want to see that one. Okay, end of this video. Thanks very much. I'll see you in the next one. I'm off by now out of here. Goodbye.